Hello, Assalamualaikum. My name is Za'im Hakimi, and today I will explain about Lab 2, Task 1. So now, I will explain about the Task 1. So as you can see, this is the coding that have been given in the lab sheet. Now first, let's run the output. So as you can see, the result output show the memory as the output. Now I will explain how the programming it works. So in this coding, at the word populate, we use the data type of the string copy, and the malloc. The malloc is defined as the create of single type of size memory. If you can see in the malloc is the memory allocation which is used to store the character. To store the data type. As you can see, the data type is character, and the size we can put a number, and we use the 7 as the size number. Next, in the line number 9 is the string copy, which it store the data type of string and use the memory as the argument. At the line number 11 is the data type of string, which also we use the same argument, which is it the memory. Now let's say I want to change a little bit argument. At the string copy, I put the memory 2. At the data type string, we put the memory 1. So now let's see the result output, what happened. So as you can see, the result output show the memory 1, which it store at the data type of string. The output not show the result of the memory 2 at the string copy, because at the data type of string copy, it already caused the problem. Means at the data type of string copy, the data type memory already leaked, which means that there are some data have already missing. So that's why in the data type of string copy, the programming cannot read and deny, which means it jump into the next data type of the data type of string in the line number 11. It read the memory 1. So now let's say we want to modify and to find the properly memory allocated. Let's say I delete the data type of string. Now let's run and show you the output. So this is the result of the output, which is memory 2. The reason is because in this programming we already modified, and the coding already ensure that in this programming that memory is already allocated properly, and there is no memory leak or missing in the programming. So that's all for me. So now I will pass to my partner groupmate to share the task.
Okay, hello. Good evening. Can you see my screen? Okay. My name is Roobakkanthan. Today I would like to present about the second part, which is about the virtual memory. Okay, for the first part, this line include standard input and output and standard library headers. These are the necessary for using function like printf, scanf, memory allocation like malloc, and free. Okay, this is the declared global variables through the programs. So this line defines structure, name, node, which hold two integer, which is VP for virtual page and PF for page table. So for this line creates a type definition for structure node as entry. This allows us to use entry as a shorthand for use struct node. So for the void set para, this function set para promotes the user to enter the parameters like main memory size, page size, and replacement policy. It calculates the number of entry in the page table E based on this parameter allocates memory for the page table using malloc and initialize the VP fields of each entry to -1. So for void map, it simulates the mapping of virtual memory address to physical memory address. It promotes the user for a virtual memory address, calculates the virtual page number VP and offset to infinity, and then searches the page table to find the corresponding entry. If the page is not found, the page table index it's not perform page replacement based on the replacement policy, either LRU or FIFO. If the page found and is not a page fault, it updates the page table. If the page is found and it's the page fault, it adds on the page table and it updates the last pointer as one set. Okay, this is for the print page. Prints the content of the page table to the LSET index. This is the function to the queue. Freeze the dynamically allocated memory for the page table if it not the already null. Okay, for this integer main, this is a main function which provides the menu-driven interface to the set parameter map virtual address and print the page table. And for the exit the program, it repeats the promotes and the user input until the user chooses to exit things. That's all from the coding. Come, let's rerun the output. For the output, okay. As we follow our lab sheet, first we select the parameters, which is the size of word 4096, and the page size is 1024. And the enter and the replacement policy, we must use the LRU for these steps, which is 0. Okay, for the map virtual address, we need to select the second choice. For the first one, 6142, it shows for page fault. For the second one, 2310, it also shows page fault. For the third one, it also shows page fault. For the fourth one, 2049, yes, we finally found a memory address access, which is virtual address 2049 maps to the physical address, which is 1025. For the fifth one, we have the same problem, which is page fault. For the last one, it also say, oh, sorry. For the last one, yep, it is undefined, which is the value are above the main memory size. Okay. In the result page, fault, the page table is updated like replacing an extension entry according to the LRU policy. Okay, now let's see the print page table. Okay, we can see VP2 maps to PF1, which is representing the mapping of the virtual page to physical frame 1 after the first page fault. For the second one, VP2 maps to the PF1, which is representing a potential duplicate entry possible to how a page fault are handled in the code. For the third one, VP2 maps to PF1, another potential duplicate entry. For the last one, VP8 maps to PF1, which is representing mapping of virtual page 8 to physical frame 1 after a page fault. So we exit the program. Right. That's all from me. Thank you.